Unit 12.1, Transformations of Exponential and Logarithmic Functions. Exponential and logarithmic functions are inverses. So that means if we were to plot both of these graphs on the same graph, they would be a reflection of each other over the line y is equal to x. So we're going to talk about these two functions and look at the properties of each of the parent functions. So starting with the exponential parent function, we have f of x is equal to 2 to the power of x, or f of x is equal to b to the power of x, where b can be any number. Okay. For exponential functions, the asymptote is always going to be a horizontal line. And for the parent function, that line is y equals 0. Our domain is always going to be all real numbers. And our range is based off of the asymptote. So since the asymptote is at y is equal to 0, that means our function doesn't go below that 0. So this is going to be 0 to infinity with a parenthesis indicating that we do not include this value. Okay. Then we have the parent function of log. So we have f of x is equal to log base 2 of x, or this can be written as f of x is equal to log base b of x, where b is any number. Okay. Here, the asymptote is a vertical line, so remember, it's going to be everything opposite than the exponential function since they are inverses. So this is a vertical line at x equals 0, and then our domain is going to be the same as the exponential's range because they're opposites. So 0 to infinity, and then the range would be all real numbers. It's important here to note that these transformations that we're going to do on these functions not only affect the function, but also affects the asymptote and the domain and range. So for exponential functions, the value d is going to affect its asymptote. And for logarithmic functions, the value c is going to affect the asymptote. Okay, so instead of it being y equals 0 or x equals 0, it's going to be dependent on those transformations. Okay. You should recall that the transformations we see in this unit is exactly the same as the transformations we see in every other unit. So for the value a, if it's greater than 1, it's a vertical stretch, less than 1, a vertical compression, and if a is negative, then we have a reflection over the x-axis. Okay. For b, if b is greater than 1, we have a horizontal compression by the reciprocal 1 over b. If b is less than 1, we have a horizontal stretch by 1 over b. And if b is negative, we have a reflection over the y-axis. Okay, now c. If we see x minus c, that means we're going right, and x plus c means we're going left. And then lastly, d, remember, affects whether we are going up or down. So if it's positive, we're going up. If it's negative, we are going down. Okay. So let's look at example 1. Example 1 says the graph of f of x is equal to 2 to the power of x is transformed to create the graph of g of x. This is an exponential function, and when describing the transformations, remember we always label our a, b, c, and d. So a, there is nothing there. You might be thinking, well, miss, there's a 2. Why is the 2 not a? Well, notice that there is a 2 in the original function f, and there is a 2 in the new function g, which means this is not a change in the functions. This was just part of the original function. So there is no a value. If we were to see an a value, there would be something extra in front of that 2. So a value in maybe parentheses. Okay, b, there is no b value. So again, we'll put none. C, we see x plus 3, which means we're going to go left 3. And then d is negative 2, which means we are going to go down. Now it wants us to sketch the graph of the transformed function. So in order to do this, since we're given the parent function, we are going to look for some points on the parent function. So remember, these points are all on perfect corners. And we're going to follow the transformations for c and d to find the new points for g of x. So we're going to go left 3, down 2. So starting here, I'm going to go left 3, 1, 2, 3, down 2, 1, 2. That's going to be my new point. And I'm going to do the same thing for every single point that I highlighted here. So left 3, 1, 2, 3, down 2. And I think there we go. Right? 1, 2, 3, 1, 2. Sorry, I'm like all over the place. Okay, 1, 2, 3, down 2. There we go. 1, 2, 3, down 2. And then 3 down 2, and then notice we have this line going up in that direction. Okay, then it says state the new asymptote, domain, and range. So since this is an exponential function, remember that this is affected by the value d. And since d is negative 2, our asymptote is going to be y equals negative 2. Okay. Same with our range. Our range is going to be negative 2 to infinity. Notice that these values are all affected by whatever d is, so whatever our transformation of going up or down. And then our domain stays the same to negative infinity, positive infinity. Okay, number 2. The graph of f of x is equal to log of x is transformed to the graph of g of x. Name the transformations. So first thing you should have noticed here, that in the function of g of x, it doesn't actually say log x, it just says f. So we have to rewrite this as g of x is equal to 1/2 log x plus 4. Okay, so if you see an f in that function, that is calling the function of the original. So think of it as them taking like a shortcut. So instead of writing out the entire function, they're going to shorthand it and just put f. Okay, we know that, so we just plug the log back in and make it look like what the transformed function should. Okay, now I'm going to label my a, b, and c. So a is 1/2. That is a vertical compression. And then c is equal to x plus 4, which means I'm going left 4. Notice that there is no b or d, so that I'm just going to write none. Then it wants me to select the correct transformed graph. So if you recall from above, the parent function of log of x looks like this. So what I'm going to do is I'm going to draw that parent function on every single graph. And I'm going to be able to choose which graph shows the correct transformations of a vertical compression, so something getting squished down and then moved to the left. And if you notice, it's this graph right here. Okay. Then it says state the asymptote, domain, and range. Since this is a log function, remember that the asymptote and the domain is affected by c. And since c is telling us to go left 4, that means we are going to write this as x equals negative 4 and our domain as negative 4 to infinity. And then range stays the same for log. It is always all real numbers. Okay, number 3. It gives us the graph of f of x and of g of x, and it wants us to label all the transformations. So I'm going to label my a, b, c, and d. So a is 6, which is a vertical stretch. I do not have a b value, so I put none. And again, I know that because this 3 is from the original function f. And then c is x plus 4, which means I'm going left 4. And d is 2, which means I'm going up 2. Number 4, I have f of x is equal to log base 2x, and then my transformed g of x. Notice that they did a little shortcut by doing f. Excuse the bell. So I have g of x is equal to negative 2 log base 2 of x plus 3. And then I have to label my a, b, c, and d. So a is negative 2, b is none, c is none, and d is 3. That negative 2 tells us two things. There's going to be a reflection over the x-axis and a vertical stretch by 2. And then d equals 3 says it's going to go up 3. Number 5 wants us to write the new function. So vertical compression is a. 4 units to the right means x minus 4. 1 unit down is minus 1. So this is going to be g of x is equal to 1/3 e to the power of x minus 4 minus 1. Number 6, reflection over the x-axis is a equal to negative 1. Vertical compression is a equal to 1/3. 9 units to the right is x minus 9. 4 units up is plus 4. So this is going to be g of x is equal to negative 1/3 log base 2 of x minus 9 plus 4. And then lastly, number 7, I have g of x is equal to 3 units to the right means x minus 3. 1 unit up means plus 1. Vertical stretch of 8 is a equal to 8. And reflection across the y-axis is b equal to negative. So this is g of x is equal to 8 natural log of of negative, and then x minus 3 plus 1.